Hello, everybody. Thank you very much for having me. Welcome to this talk, Less Code, More Confidence. My name is Tonchis, and I'm here to tell you that I hate debugging. Now, I know that there's better people than me out there that truly believe that behind every bug, there's a lesson to be learned. And that's a very romantic idea, but it's just not who I am. And I'm pretty sure everybody in this room has a story similar to this one. So it's maybe 5, 6, 7 in the afternoon, you're in the office, 3 to 4 hours into a debugging session that doesn't seem to have an end, and you're just sitting there on your computer making random changes to the code in the hopes that the bug will go away and you can finally go home. Does this sound familiar at all? Have you been in this situation before? Okay, cool. So what I actually hate about this is this feeling of being lost in code. So I know that I'm missing something. I just could be like a devilish little detail or something super obvious that I'm just not seeing, but I know that I'm missing something. So what I think is going on here is actually legacy code. Now, the way I like to think about legacy code is not as some old Fortran system running on super old servers, but rather as code that nobody in the team knows how it works anymore. So it doesn't matter if you're installing the latest version of Rails. If you're not able to go through the source code and truly understand how it does what it does, then you've immediately introduced legacy code into your project. This is why it's so important to me to work and write code that is easy to understand. Because I know that for every feature that I'm running on production, there will come a time when how fast I can load that code into my head is going to make a huge difference when debugging. This is why the less code movement or counterculture, however you want to call it, resonates a lot with me. It's this idea of favoring small libraries over huge frameworks. But simplicity, minimalism, less code, these are buzzwords that can be easily thrown around, but are actually very hard to pin down when it comes to actual code. So rather than discussing the philosophies about these ideas, in this talk today, we're going to try to find where is the less in the code. We're going to go over 3 principles, 3 ideas, and we will be reviewing some open source libraries and find out how some of them favor these ideas, but others go against them. Now, we will be reviewing open source, and we will be pointing out issues in them, but before we actually start, I want to make a disclaimer. We are not the code we write. And it's very easy to forget this. It's somehow embedded into our developer DNA. So despite any critics I can make up here today, if you are writing open source, then my thanks to you, because it's something that's very time-consuming. It takes a lot of effort of people, for maintainers and the people doing it. So if you're writing open source, kudos to you. So let's get started. Readability. Now, the way I see it, code has 2 purposes. It tells computers what to do, and it explains humans how it's done. So let's take a look at our first example of the day. Assert URL is a small gem that I wrote. And imagine for a second that you have a /foo endpoint, and you want to test that when you are posting to it, then the location header of the response contains /foo/1 as part of the path. Now, this is a test that you can probably write. And what assert URL does is it gives you a number of helper functions, so you can target individual parts of the URL without having to match the whole string. The nice thing about this is that this test is now immune to any changes in the host or the port or any other part of the URL you don't really care about. So let's dive into how assert URL is actually implemented. When I first wrote assert URL, I had each individual method written with its own body. So assert host equal, then assert path equal, etc. And after I was done, I realized that these methods look pretty much alike. And my refactoring reflex kicked in, and I was taught that good developers don't repeat themselves, so I wanted to leave everything as dry as possible, and this is pretty much what I ended up with. So you can see here on line 8 or 7 says there's the define method call, and that is inside a loop of parts, and parts is defined above there. And you can look at this and say, yeah, well, this is pretty much OK. But after I was done writing this, I asked myself, well, why write this code this way? Who is this code optimized for? Is this code somehow more performant? Is Ruby going to load this faster into memory? Well, the answer is no. I mean, this code is not optimized for anybody. So I chose to optimize for readability. I went back to my original approach, and I expanded each of the method definitions with its own body. Now, of course, this takes a bit more lines of code. So why is this actually better? Well, by optimizing for readability, we quickly realized that the number of times that you read code is actually a lot more higher than the times that it is written or changed. But beyond this, optimizing for readability makes this code easier to load into your head, which in turn will mean less legacy code. Now, readability is a huge topic. We could discuss this for hours, how we write the variables or the long names or not. But at the end of the day, it's all about the form or the shape. It's how we write what we write. So in this next section, we'll talk a little bit about the content. Explicit is better than implicit is one of the 20 principles in the Zen of Python. But beyond the generality of it, what it means for us as library writers, it basically comes down to what we choose to show versus what we choose to hide. And the balance between these two is what we call an abstraction. So let's take a look at another example. Device. How many people here know device? OK, pretty much everybody. So this is a Ruby gem. For those of you who don't know it or have never used it, it's a Ruby gem to do user authentication. And what you're seeing here is pretty much everything you need to get it up and running. So you require device. You tell to your model, hey, device, this model is database authenticatable. And then in your application controller, you can just call before action authenticate user. So this is super practical, and it'll get us up and running very fast. But it's what I like to call a dangerous abstraction. So imagine for a moment that you actually write this code, you ship this to production. Then a couple of weeks go by, and your boss tells you that the CEO of the company just can't log into the website. So now it's debugging time. You sit down, and you say, OK, let's make sure that all my params are going to the right places. And you start by looking at the authenticate user method here below. If you make your way into device's source code, you will find this. Now, there's not a lot to go on here, but you can see here on line 118, it says warden.authenticate. Now stop. At this point in our story, you have two problems. One is that you have a bug in production. And two is that you need to find out what warden is and if it's related to your problem or not. So why does this make device a dangerous abstraction? Because we are learning about how it works in the worst moment possible, which is after we have implemented it and it's already running on production. So how does explicit actually look like? Let's take a look at another example. It's a library called Shield. It's also a Ruby gem to do user authentication, but it works a little bit differently. You have to make Shield work, you have to define a method named fetch, and that method receives a username, which is a plain string, could be an email or whatever you are using. And inside of it, it is our job to actually reach into the database or the network or whatever we're storing them and give a user to Shield. After that, we can call user.authenticate, give it the username and the password, and that's it. So let's take a look at how authenticate is actually written. If you see here in line 79, we can see user equals fetch. Now, the nice thing about this is that after those 2 or 3 weeks, when you are debugging, seeing this will help you make the mental connection back to the time where you were implementing it. So what's very interesting for me here is that Shield is not hiding everything about authentication to us. It is making us a part of the solution. So it's making the strategy explicit, but at the same time, it's also hiding complexity because we don't care about checking for the password or anything like that. Now, even though hiding complexity is the very reason why we have abstractions in the first place. When we also hide the strategy behind our solution, that's where the feeling of black magic comes from. So the idea here is that by making our strategies explicit and our solutions clear for the user, we will have a less feeling of black magic and therefore less legacy code. Now, this next section is my favorite one. And there's no better way to introduce it than with a wonderful quote that I'm not going to read this in French because I don't want to murder your beautiful language. But it basically says, perfection is achieved not when there's nothing else to add, but when there's nothing else to remove. So let's talk about avoiding redundancy. By redundancy, what I mean here is basically giving your users the choice of doing one thing in more than one way. Now, while this may be sometimes convenient or even fun to have, flexibility can be a bit of a double-edged sword. Because when you have more than one way to do one thing, it'll be harder for a group of people to write homogeneous-looking code. But homogeneous code is actually more predictable, and more predictable code is more readable. But this quest for homogeneous code is not something new at all. I mean, if you think back to, for example, Python's significant white spacing, one of the nice things about that is that it makes everybody indent the code the exact same way. Or, for example, Go has a Go format tool, which literally formats the source code for you. So let's see how redundancy looks like. Fat, also a gem that I wrote. I wrote this before we had dig in Ruby. It stands for find at or fetch at. And it's basically meant to navigate a hash in a safe way to avoid the undefined method brackets for nil there that we all hate to see when we're trying to access some JSON or something like that. So there's 3 ways in which you can call fat. The first argument is always the hash. And then you give it all the keys that you want to navigate through up until the final value. So you can either give it each of the keys as an individual argument, or you can concatenate those keys with a dot. And you can also concatenate the keys with a colon if you want to signify that the keys are actually symbols instead of strings. Now let's dive into how fat implements this little bit of logic. So fat is a C extension, it's written in C. But very quickly, what's going on here is that I'm seeing if I only have one argument, then I'm going to try to split that by a dot. If I find out that that split is empty, I'm going to try to split that by the colon. And if that is not empty, then I will convert all those keys into symbols and finalize there. Now, roughly 15, 17 lines of code into our work here, and we are no closer to actually solving hash navigation in a safe way. So my question here is, well, is this actually worth it? Well, having that code there means there's more work for the reader to understand when you try to find out how fat is implemented. And you have to multiply that by every reader that is actually trying to do that work. So it's quite a lot of effort. But also, it means that there's more room for bugs or attack vectors. Anything can go wrong in those 15 lines of code, and it'll just derail you from actually navigating the hash, which is what you want. So I asked myself, well, can I really live without this feature? In FAT's case, the question is pretty easy. We can just remove the concatenation feature and have everybody pass the keys as arguments and be done with it. But more importantly, the question that is behind this is how can we actually find redundancy like this one in our daily code? Well, the question that I like to ask myself whenever I'm writing a class or any piece of code is, are all my users using 100% of the code that I'm shipping or not? Now, this question is not something new. We already talked about code coverage when we discussed testing. So are our tests passing through 100% of the source code or not? This is a very similar idea, but when we were talking about the interface of a class, so interface coverage. However, here, flexibility is kind of easy to spot, but there are other ways, more subtle ways in which flexibility can sneak up on you that is not so easy to spot. Let's talk about Cuba for a moment. How many people here know Cuba or having used it? All right, so Cuba is a wonderful HTTP routing library, that lets you match a part of an HTTP request with a block of code. So imagine for a moment that you have the get/home request. And this piece of code here will mean that line 5 will match the home part and delegate the execution into the block. Then line 6 will match the get, which is the verb, delegate the execution into line 7, which will write I'm home into the body. So we can actually do the exact same thing if we flip the order of the nested blocks. So first we match the path, the verb, then we match the path, and then we'll just finish with the body. Now, no surprise, we can also do the exact same thing if we do only one on call with both arguments here and avoid the nested block. So let's take a look at how Cuba actually does this. This is the on method, but never mind all the noise here, just focus on these two lines, 171 and 173. And you will see that on doesn't really care about the context in which it's being called. It only cares about matching the arguments that you give it, and it'll then yield the control back into the code. So the interesting thing here is that Cuba's flexibility is not baked in with extra code like with FAT. There's no parsing of any sort. Cuba's flexibility is in here by design. So is this really so bad? Well, in practice, for every Cuba project I ever work with, the team and I would have to agree on, OK, so how do we write our routers? Do we match all the get first, and then we match the path? Or do we, are we going to write out everything in one line? How are we going to do this? If this discussion sounds familiar, it's because we have this all the time. We spend a lot of time in our communities and in our teams discussing code conventions. So there's a lot of effort put into writing readmes and seeing if the pull request complies with the convention or not. And the good news is that by keeping flexibility at bay in our tools, we can actually cut down a lot of the time we spend here. So the final example I want to show you is another tool that's called Cyro. And Cyro is sort of the evolution of Cuba, which is why they look so similar. And same idea here. You have the get/home. Here, line 5 will match home. Line 6 will match get, and you can then write into the body. But if you actually flip the order of the nested blocks, this request will be a 404. Why? Because the get block on line 5 will not match the request. If we dive into how get is implemented, we will see here on 177 that get is actually asking if the path has been consumed or not, if it's root or still has something in it. So the nice thing about this is that all the Cyro apps actually look more alike than Cuba apps, which in turn means we'll have more predictable code. And of course, this means less legacy code. So this is the end of the ride here, and I just want to summarize what we discussed here today. So less code, minimalism, simplicity, these are things that are very hard to pin down when it comes to actual code. And this is just my way of making sense out of minimalism and this whole philosophy. So we discussed optimizing for readability, making your solutions explicit, and avoiding redundant interfaces. So as I said at the beginning of the talk, debugging can be hard, stressful, and very frustrating. But I truly believe that these ideas will not only alleviate some of the challenges that come up from living within each other's code, but it'll actually take us one step closer to elevating coding into a form of art. Thank you very much.